Okay, so this question has a temperature composition diagram, and it asks, what is the mass percent of hexane in a mixture with heptane if the mole fraction of hexane is 0.20? And then they show this temperature composition diagram. Okay, so let's try to answer this question. So this is question number 6. Okay, so they give us the mole fraction of hexane. So to help us answer this question, step 1 is to assume that we have 1 mole of the total mixture. So this will help us calculate the mole fraction of heptane. Okay. So I'll just write down an explanation, just like a sample equation showing how mole fraction is calculated. If we had the mole fraction, which can be denoted as X, the mole fraction of A, this is equal to the number of moles of A divided by the total number of moles. Okay, so then if they gave us the mole fraction in the question, then we can calculate how many moles there are of hexane. Okay, so I just showed that if we assumed 1 mole of the total mixture, then there is 0.2 moles of hexane in the total mixture. And like I mentioned earlier, because we know the mole fraction of hexane is 0.2, we can calculate the moles of heptane. So I'll put mole fraction of heptane is equal to 1 minus 0.20. Since we know that this mixture only contains hexane and heptane, if 0.2 of that, of 1 mole of the total mixture is hexane, then we know the remaining 0.8 will be heptane. And then since we know the mole fraction, we can also just write that the moles of heptane is 0.8 moles. Okay, so now that we know the number of moles of both of these gases, step 2 is to find their molar masses. So let's say we didn't know the molar masses of these compounds. Let's just quickly draw them out. So for hexane, this is a 6-carbon chain. So there's no double bonds or anything. And we're just going to fill in the rest of the bonds with hydrogens. So there are 6 carbons and 14 hydrogens. So if we were to find the molar mass of heptane, it would be the molar mass of carbon times 6 plus 14 times the molar mass of hydrogen. Okay, so this gives us a molar mass of 86.2 grams per mole. So if we wanted to do the same thing for the heptane, then it would be 7 carbons and 16 hydrogens. So this would give us a molar mass of 100.2 grams per mole. Okay, so let me just try to separate the different parts. So step 3, now that we have the number of moles and we have the molar masses, we just need to find the total masses of both of the gases. So let's recall that mass is equal to the number of moles times the molar mass. So the mass of hexane would be 0.2 moles times 86.2 grams per mole, which gives us around 17.2 grams. And the mass of heptane is 0.8 moles times 100.2 grams per mole, which gives us a much larger value, around 80.16 grams. Okay, so the question asks for the mass percentage of hexane. So we have everything we need to calculate this. So the mass percent of hexane is equal to the mass of hexane divided by the total mass of the gases. So I did not leave myself a lot of room, but we know the mass of hexane was 17.2 grams, and the total mass is just the 17.2 plus the 80.16 grams from the heptane. All of this times 100. I'm going to write it up here. Gives us a value of 17.7%. Okay, so let's kind of fit that in the corner. So the answer is 17.7 mass percent of hexane. So now let's see what the junior tutor said. To assume 1 mole of the mixture the mole fraction is equal to the mole A divided by the moles in solution. Okay, so 0.2 is equal to the moles of hexane divided by 1. So moles of hexane is 0.2, moles of heptane is equal to 0.8. Considering the following molar masses, for heptane they had 100.12, and for hexane they had 86.18. And then they found the masses of both of hexane and heptane. So around 80.096 grams of heptane and around 17.236 of hexane. And they found the mass percent by doing the mass of hexane divided by the mass of the mixture. And they also got around 17.71%. Yep, so I can say that this solution is correct.